Hello class, my name is Yash Khangas and I'm representing Group 1 from ICT 101 Mathematics Assessment 2. So today we'll be looking at the presentation for the report that we have already created. So I will let you go through all the slides. So let's start with the presentation. So as I already said that this is Assessment 2, which is group presentation for the class. And for starting with the introduction, we have this presentation summarizes the outcomes of our group assessment, focusing on various mathematical computing concepts, which we will discuss, which have 5 concepts, which are sets, relations, mathematical inductions, functions, set theory, Cartesian products. We will describe each one of them with examples. So let's start with the first one, variables and sets. So here we will also take some examples. We'll describe the topics and theories. Let's start with the first, variables and sets. So let's assume the range of patients would be R, which the range would be maximum minus minimum. So if we take the maximum as 95 and minimum as 1, so the range would be 94 years. So you can apply this theory for all the age groups. And for the patients under 18 years, we can also look at the E is equals E less than age or and more than of less than of 18. So we can arrange these kind of things according to the formulas too. So the number of patients under 18 represented by the cardinality of set E. And for the patients over 65, we can say that set over 18 would be more than 65. The representation by the number of the patients over 65 is by the cardinality of set over 18. And you can also do the median age for sorted ages. For median ages, we have various formulas for it. So therefore, the median would be 45.5. Now moving on to the second topic, which is Cartesian product and relations. So for creating the set for the dishes and drinks, let's assume that we have dishes as appetizer, entries, and desserts, and drinks we have alcoholic and non-alcoholic. So these are just some assumptions to understand the topics. So F as the set of type of dishes, and the dishes we have already chosen, which would be appetizers, entries, and desserts. And D would be the set of drinks, which would be alcoholic and non-alcoholic. Cartesian product of the set of dishes and set of drinks would be multiplications with various things, like first one with the first one, then the second one, which is depicted in the formula. We need to understand the formulas carefully to completely understand the mathematical procedures. And the relation between the set of dishes and set of drinks would be like this. Whether the relation is a function or not, in order to determine the relation R is a function, we have to check if each element in that set of dishes is related to exactly one element in the set of drinks. So this is a prerequisite kind of thing to see if they have the relation in a function. So here we can see appetizers are related to non-alcoholic drinks, entries are related to alcoholic drinks, desserts are related to non-alcoholic drinks. These are some relations which we have used, or examples that we have used to better understand the topic. Each dish related to one type of drink, the relation is a function. Now moving on to our third topic, which is functions. We will now look at functions in a more brief way. So the function which represented the total cost of renting a car for a given number of miles driven would be C equal to 30 plus to 0.5 E. So 30 is the basic price to rent a car. 0.25 E represents the additional cost per mile driven. So per mile we will multiply by 0.25. And for calculating the total cost of renting a car for a 100-mile trip, we will just need to use 100 with the E. We just need to change the positions. So the C of 100 would be C 30 plus 0.25 into 100, which would be 30 plus 25 is equals to 55. So therefore, the total cost for renting a car for the trip to 100 miles is 55. We just need to change the numbers from E to whatever the miles we have. So here, if we choose 100 miles, then the price would be $55. And now distance driven by the car with a total cost of $100 would be 30 plus 0.25 equals 100. So we will just need to do basic mathematics to find the value of E. So here we can see by multiplying it by a simple method, so you can see that the E is 280. That means for a total cost of $100, we have driven the car for 280 miles. And for domain of the functions, the domain of the function can be represented as all the possible value of all the input variable E. And for this case, domain consists of all the positive real numbers, as you cannot drive any negative distance. So the domain of the function is this. So here we have some formulas and some concepts, easy stuff. We just need to figure out the whole thing. And now moving on to our fourth topic, which is mathematical induction. So when n is a positive integer, prove the sum of first n even number is n bracket n plus 1. So here we are just going to solve something. Suppose the statement is true for some arbitrary positive integer k. So suppose the sum of first k even numbers are k plus 1, that is e k is equals to set of k is equals to k plus 1. We want to show that if the statement is true for k, it is true for k plus 1 as well. The sum can be written as this after considering the sum of k plus 1 even numbers denoted as ek plus 1. By the inductive hypothesis, we know that ek is equals to k plus 1. Then k plus 1th even number is 2k plus 1 because it is the next even number to 2k. Therefore, after substituting these into the expression for ek plus 1, so if we need to just substitute the things, we can say that thus e of plus 1 equals to k plus 1, k plus 2, that matches with the desired value of n plus 1. And moving on to the next topic, which is mathematical induction. The first few terms of the sequence, we have, if we change some digits, then if we put some like numbers in it, then we can have some answers. Base case for the proof. The base case is when n equals to 1, where the sum of the first even number is 2. Inductive hypothesis. The statement that holds true for some arbitrary positive integers k, that is the sum of the first even numbers is k plus 1, is known as the inductive hypothesis. To prove the statement of the base case is true, it is shown above the sum of first even is 2, and therefore the statement is true. As it already shown in the steps above, supposing the statements hold true for some arbitrary positive integers k, we have proven that it is also for k plus 1. After deriving the expression for e k plus 1, which defines with desired form n plus 1. And now moving to our last topic, which is our fifth topic, which will be set theory. So for creating the set for each measure, according to given information, b of 200, which is the number of business majors, and e of 250, which is the number of engineering majors, and L will be the remaining number of students with liberal art majors. And we have a total of 500. So therefore, sets can be represented as BEL, which is business majors, engineering majors, and liberal arts majors. And the union of business and engineering majors would be BUE, students with business majors, engineering, and all of those stuff. So we can say, therefore, B is the number for business majors. Intersection of two sets is denoted by this relation. This is a kind of a thing, how we denote some things. And at the last, number of liberal arts major would be total students minus business majors minus engineering majors. So we will have 50. Therefore, there are 50 students in liberal arts. And this is the end of our presentation, where we have looked at 5 concepts in mathematical induction, set theory, functions, and Cartesian products. So these all can be used by professional as well as students to solve some complex hypotheses or some simple terms as well. So this was me, Yash, from Group 1, and this is the end of our presentation. Thanks for watching.